We are in section 3.4, ratios and proportions. Now I know you've done ratios and proportions before, but we are going to incorporate some new concepts into today's lesson. As review, a ratio is a comparison of two numbers by division. That's it. A ratio can be written as A colon B, which would be read as A to B, or A divided by B. Basically, it's just a fraction. Now, B cannot be equal to 0. The second vocab word is a rate. If A and B represent different units, different labels, then what you're talking about is a rate. For example, gas right now averages $3.62 per gallon. That's a ratio. However, since they're two different units, we're talking about dollars per gallon, the ratio is called a rate. So now let's look at our first example. The table at the left gives prices for different sizes of the same brand of apple juice. Find the unit rate for each. Which has the lowest cost per ounce? This is stuff you've done before. So as you should remember that if you're trying to find a unit rate, you need to find out how much per one there is of something. So if we're looking at unit rate, each of these have to deal with, whoops, did not mean to do that. Each of these have to deal with dollars and ounces. So if we're looking at dollars and ounces, we have to figure out how much money it is per ounce. So then what you do is take the money divided by the ounces. So 72 cents divided by 16 gives us approximately 4.5 cents per ounce. $1.20 divided by 32 ounces gives us approximately 3.75 cents per ounce. I'm just leaving them using the dollar sign. I'm leaving them like that. And you can round as well. $1.60 divided by 64 gives us approximately 3 cents or about 2.5 cents per ounce. So if we're looking at it, which one's the best deal? The best deal would be the 64-ounce bottle has the lowest rate because that's about 2.5 cents. If you round it up, it'd be approximately 3 cents per ounce. Example number 2. You do not need to write this down. This is on page 143. I do want you, however, to show the work. So we have 3 things that this asks. In 2004, Lance Armstrong won the Tour de France, completing the 3,391 kilometer course in about 83.6 hours. Find Lance's unit rate. So there's the first thing we have to do, which is his average speed. The second thing, write a rule to describe the distance he cycles. Let me erase that there. D as a function of the time t he cycles. And lastly, cycling at his average speed, how long would it take him to cycle 185 kilometers? So if we're looking at this, we have to start with the red. So let's start with the red. Find the unit rate, his average speed. Now, once again, we're talking about kilometers and hours. So we have to figure out kilometers per hour. So his distance is 3,391 kilometers for 83.6 hours. So if you divide this, this gives you an average speed. Now, if you don't know what I'm doing here, this means approximately. 2 wavy lines means approximately. You could say about 41 kilometers per hour, or you could say 40.6 kilometers per hour. That's a unit rate. Using that, we have to write a function. A function is just an equation. So we're going to write our second part, which is write an equation. So we have to write it d as a function. So that means distance. His distance is what? Now, if you remember what distance is. Distance is d equals rate times time. Rate is speed. The distance is what we don't know. The time we don't know. But what do we know? His rate. What's his rate? 40.6. So there's part 2. The distance is 40.6 miles per hour. That means every hour he goes 40.6 kilometers. So if we look at step 3 is use the equation to determine how long would it take him to cycle 185 kilometers. So 185 kilometers represents distance. So we plug that in for D. 185 equals, what's his rate? 40.6 T. Now you just solve the equation. Divide both sides by 40.6. The time is approximately 4.6 or 4.56. So, traveling at his average speed, how long would it take him? We don't want to say 4.56 hours. That's not what you would tell someone. You could say a little over 4.5 hours. Next, we're going to convert units. This is not the easiest thing for a lot of students. So we're going to follow along. You don't need to write this down, these couple sentences here, but I do want you to write down the problems that we're going to do together. When converting from one unit to another, as in hours to minutes or minutes to hours, you must decide which conversion factor will produce the appropriate unit. Now, a conversion factor, so you understand what that means? That means, for example, 60 minutes is an hour, or an hour is 60 minutes, or 1 foot equals 12 inches, or 3 feet in a yard. Those are all conversion factors. So you have to determine which conversion factor will produce the appropriate unit. This process is called unit analysis. So let's do an example together. So we have a cheetah. A cheetah ran 300 feet in 2.92 seconds. What was the cheetah's average speed in miles per hour? So the first thing you have to understand is we are starting with feet per second. We have to end up in miles per hour. We can write all of these as ratios or as rates. So let's write what we know first. We know that we can start with 300 feet for 2.92 seconds. Notice I put the labels. The labels will help you immensely. What I'm then going to do is I'm going to actually make a big line, and then I'm going to do a whole bunch of fractions in here. So we're going to do this a couple times. And I'm hoping this will make sense. Now, if you would like to do this instead, fraction times a fraction times a fraction, you could do that as well. So you could have 300 feet over 2.92 seconds, a conversion factor in the next fraction, and so on. So here's what I always did when I was in school. I looked at feet and I looked at seconds. What do you want feet to end up as? You want it to end up as miles. What do you want seconds to end up as? Hours. So you have to start giving me conversion factors. Now, you should know all these. These are all conversion factors you should at least have seen, heard, or used before. So let's start with feet. What do we know about feet and miles? Feet and miles. 1 mile has 5,280 feet. So notice at the top, feet is at the top. That means the label feet has to be at the bottom because anything divided by itself cancels out. So feet would have to be at the bottom. So what do we know? 1 mile is equal to 5,280 feet. This is called a conversion factor. Now, I want you to notice what happens here. Feet divided by feet is gone. What do we have here? We have miles. That's good. Miles is what we want. So now we have to go from seconds to hours. What do you know about the number of seconds Now, you might not know how many seconds there are in an hour, but what do you know about seconds? There are 60 seconds in a minute. Now, notice where seconds is. Seconds is located at the bottom. So we're going to put 60 seconds, the label seconds on top now, 60 seconds in 1 minute. Now we keep going from there. Notice what happens. Seconds divides with seconds, they're now gone. We currently have miles per minute. Miles per minute we don't want. We want miles per hours. So what do we know about minutes and hours? We know that there are how many minutes in an hour? Well, there's 60. So because minutes is on bottom, we want to put minutes on top. So it cancels. So 60 minutes in 1 hour. And once again, the label of minutes, one on top, one on bottom, they cancel. So what you are left with is this. 300 times 1 times 60 times 60. You're going to give yourself a numerator. On the bottom, 2.92 times 5,280 times 1 times 1, and then you divide the numbers. If you did that, you would get approximately 70 miles per hour. So the cheetah's average speed was about 70 miles per hour. Let's do another example. Example 4. A sloth travels 0.15 miles per hour, convert into feet per minute. If you would like, you can pause the video and do this yourself. So I've started the problem out and written 0.15 miles per 1 hour. So we want to go to feet and minutes. So let's start with miles. We want to convert it to feet. So what's the conversion factor that you would use? Well, we know that 1 mile, notice I put the mile on bottom since it's on top on the other fraction. 1 mile is 5,280 feet. Miles cancel. Now notice this time I'm actually using 2 fractions if you want to do fractions, rather than what I did last time, which was kind of a little chart. So now I have feet. That's good, I have it. The next thing is I have to go from hours to minutes. How many minutes are in an hour? Well, there's 60 minutes in 1 hour. And why did I put the hour on top? Because the label of hour is on the bottom. If the hour was on top, then this fraction over here, the conversion factor, would be switched. So hour here, anything on top cancels with anything on bottom. I am left with my 2 labels of feet and minutes. So now you would take 0.15 times, and if you wanted to, I'll do it with you here, 0.15 times 5,280. That gives you 792 feet. And then 1 times 1 times 60, that's 60 minutes. So now you divide 792 divided by 60, gives you approximately 13, or you could do exactly 13.2 feet per minute. The last thing we're going to talk about are proportions. Now, this should be reviewed. A proportion, if you don't know, is when you have 2 ratios, which are fractions, equal to each other. So, for example, if you had the fraction a divided by b equals c divided by d, this entire thing is called a proportion, in which you would cross multiply to solve. So let's just go right into our examples. A, t divided by 9 equals 5/6. To solve this proportion, we cross multiply and take 6 times t and 9 times 5. 6 times t is 6t equals 9 times 5 is 45. We divide both sides by 6. 45 divided by 6 is 7.5, or you can write 7.5, or 7 5/10. B. If you had, for example, let's do x plus 4 divided by 5 equals x minus 2 divided by 7. you are going to cross multiply. That means you take the 7 times the entire quantity, x plus 4. So you would write that as 7 times the sum of x plus 4 equals 5 times the sum of x minus 2. You now solve by distributing. 7x plus 28 equals 5x minus 10. We now have to get the variable on one side, so I'm going to subtract 5x on both sides. And so that would give me 2x plus 28 equals negative 10. I now subtract 28 on both sides. That gives me 2x equals negative 38. Divide by 2, and that gives me negative 19. So my answer would be negative 19. Our last example, I want you to write down and then pause the video and solve it yourself. If you did it correctly, you would get the answer of negative 21. If you got it, great, you can stop the video. Otherwise, we cross multiply 3 times w minus 4 and 5 times the quantity w plus 6. I distribute, I get 3w minus 12 equals 5w plus 30. I now subtracted 3w on both sides, so that's the step I skipped. You can skip it if you want. Subtract 3w. That gave me negative 12 equals 2w plus 30. I then subtracted 30 on both sides. That gave me negative 42 equals 2w. I then divided by 2, and that gave me an answer of negative 21.